Hi everyone, welcome back. Today we're doing FizzBuzz, and this question is a very good practice for conditional statements. For this question, we're given an integer n, so let's say n is equals to 3. We have to check and return a string array answer where if a given index is, let's say, 1, in this case, if it is divisible by 3 or 5, then in this case, we'll give it FizzBuzz. In this case, since I is not divisible by 3 or 5, we will ignore this statement. If I is divisible by 3, we will give it fizz. If I is divisible by 5, we'll give it buzz. Otherwise, we would give back this integer as a string. So for a given number such as 3 in this case, we would get an array of 1, 2, and 3. In this case, for 1, it doesn't match any of the 3 conditional statements here, so we would set itself as 1. 2 is the same as 1, it doesn't match any of the 3 statements, so we leave it as that. But in this case, for 3, this matches the second conditional statement, so we will replace 3 with this. And this is pretty much the essence of this question. So to tackle this question, we can do a simple iteration from 1 all the way to n. And for each of these numbers, if it matches any of the conditions, we would follow these instructions and give back the respective strings. Otherwise, we'll give that index as a given string. And that's pretty much it. So it would be something like this. You have, let's say, n equals to 5. Let's try this with the second test case. N equals to 5. We will iterate through all numbers from 1, 2, 3, 4, and 5. And for each of these numbers, we will check them for conditions, and we will add each of these resultant values into a given list. So in this case, let's say we have a list like this. We will first check 1. 1 in this case doesn't match the first 3 conditional statements, so you add 1 into this list. 2 is the same. 3 in this case would match the second condition, so we would add fizz. 4 in this case would not match any of the conditions as well, so we will add 4. And finally, buzz will match the third condition in this case, so we will end up with buzz. And that's pretty much it for this approach. It was a little messy for these workings, but I hope this was clear. And with that, let's move on to implement this in multiple languages. Now that we have the general approach, let's try to implement this in Java. In this case, as we discussed, the first step is to iterate from n equals to 1 all the way to n. In this case, let's use a simple for loop to do that. Before we do the iteration, let's also initialize a list which represents the answer. In this case, let's initialize a list object over here. Let's call this answer. And to our viewers who are new, by the way, this list over here is really from Java util list, and this is really an interface. And in this case, this interface has multiple implementations that extends it. So you have Java util array list, for example, and you also have Java util linked list. In this case, we are appending values to the end of this list and we are returning it back. So frankly, it doesn't really matter if you use either implementations, but for this implementation, let's use an array list in this case. You can think of an array list as analogous to C++ vector or Python list, where the size is variable. So let's initialize an array list object over here by calling the constructor. The next step is to iterate I from 1 all the way to I less than equals to n. And in this case, we will proceed to perform the conditional checks. The first conditional check is to see whether if this I over here is divisible by 3 and 5. So let's do that. So if I %3, this is the modulo operator, and this gives you back the remainder after you divide I by 3. And this is if this is equals to 0, what this means is I is divisible by 3. In the same vein, we will do the same for I %5 equals to 0. And this is pretty much the first block. So if this first condition is true, then we will do answer.add calling the add method on the array list, and we will append FizzBuzz. Now let's check for the second condition, if I is divisible by 3. So if that's the case, we will add it with fizz. Otherwise, if I is divisible by 5, this is the third condition, then we'll do answer.add buzz. And if it fails all 3 conditions, we would add this given integer into this list. But as you notice, the list signature takes in a string, so we are not allowed to add in primitive integers like this. To fix this, we would use integer toString method over here. In this case, this is a static method to be specific, and this allows us to call toString on this integer class. So now, at this point, we got the answer, and all we have to do is run this against some test cases. Okay, this passes, and let's try testing this on the rest of the test cases, and this passes as you see. To make it easier to visualize how this algorithm works, let's try it out with a sample test case. Let's use the second test case in this case. So let's let n equals to 5. Let's also initialize the answer to be using this notation over here to keep track of its contents. The first iteration is I equals to 1, and in this case, I would fail the first condition. I is not divisible by 3 or 5. 1 is not divisible by 3. 1 is not divisible by 5. So we will add 1 into the answer over here. Same for 2. 2 is not divisible by 3 and 5. And in this case, we will add 2 into this list over here. Now we have 3. In this case, it would reach the second condition. 3 is divisible by 3, but 3 is not divisible by 5. So we will skip the first condition. 3 is divisible by 3, so we will add this into this answer over here. We'll add fizz. We hit the second condition. You get the pattern by now. 4 doesn't hit all 3 conditions. And finally 5. In this case, it doesn't meet the first condition, the second condition, but it meets the third condition. So this gives us the final answer of 1, 2, fizz, 4, buzz. And that's pretty much it. So let's talk about the worst case time and space complexity of this approach. So let's talk about time first. In this case, we are iterating through I to n. Let n to be integer n in this case. This algorithm's runtime will scale linearly with respect to n because we are going through a for loop iterating from 1 to n in this case. So the time complexity will be O(n). Adding a value to the back of an array list is very efficient, it's constant time. So we can just take every iteration as having constant time complexity. And that's pretty much it for the time complexity. For the space complexity in this case, we have an array list over here, and we are adding an element into this answer, and this addition, this size of answer would scale linearly with n, because for every single value, we're adding something into this array list over here. So the space complexity is O(n) over here. And that's pretty much it for this video. If you find this useful, please give us a like and subscribe, and we'll see you in the next video.